The top 10 changes the Earth would suffer if it had no moon. The moon plays a very significant role in our planet's behavior, and indeed in our very existence. So, what would happen if the moon disappeared? Number 10. No more tides. If you live near the sea or an ocean, you're very aware of the tides. You see the water rushing towards you or watch it flowing away. As we all know, this is mainly caused by the moon's gravity. When the moon's overhead, its gravity pulls the water towards it, making a bulge which we see as a high tide. On the other side of the Earth, it also bulges, though not quite as much. So when there's a high tide in Argentina, there's one in China too. At the same time, on the sides at 90 degrees to these high tides, there are low tides. And as the moon rotates around the planet, these tides shift with it. It happens once a day. The difference in height between low and high tides can be as much as 50 feet. So what would happen if the moon disappeared? The answer is clear to see. These tidal rises and falls would dramatically reduce by at least a third. This would flatten out the oceans and seas. Water levels at the poles would increase. Coastal ecosystems would be hugely altered. Sea snails, crabs, mussels and the like need the tides for survival. And our climate would change hugely as the ocean currents would be affected. Not good. Number 9. Slow spin cycle. The speed of the Earth's rotation is getting slower and slower. Indeed, eventually, we're going to have to change the design of our clocks because in 200 million years' time, there'll be 25 hours in a day, not 24 as now. So, no hurry, it's only by 2 milliseconds every 100 years. Though, on June the 30th, 2012, we did have to add an extra second to the world's clocks, so it is real. And when the dinosaurs ruled the Earth, a day lasted only 23 hours. Indeed, when the planet was first formed about 4.5 billion years ago, each day was merely 4 hours long. Does that matter? Yes. The climate would be vastly changed as the present-day warming and cooling would last longer, heating more, cooling more. Even an extra hour would make a huge difference. But at present, no need to worry. Number 8. A tilt too far. The Earth doesn't spin like a top or a gyroscope. It's slightly tilted by about 23.5 degrees. That's why we have seasons. For some of the year, the northern hemisphere is tilted towards the sun and the southern one is tilted away. More heat for the north, which we call summer, less heat for the south, which we call winter. And about 180 days later, it's the other way round. How did this tilt occur? There are several theories, but the most credible one is that a protoplanet about the size of Mars, which we usually call Theia, crashed into our planet, creating the moon from debris and tilted the rotation of the Earth. The moon then, through its gravity, stabilized the Earth's tilt. So, what would happen if the moon disappeared? There's some argument about its effect. Some scientists reckon that the Earth would tilt by another 85 degrees, almost turning on its side. Others calculate it would just be 20 degrees more. Either way, it's bad news. The poles would now be exposed far more to the sun's heat, and the ice caps would melt completely, and possibly new ones would form near the equator. This, in turn, would cause extreme changes to our climate. Indeed, even a tilt of 1 degree could trigger a global ice age, chilly and most unwelcome. Number 7. Mini-moons and cosmic dust. In 2018, Hungarian astronomers discovered huge clouds of dust orbiting the Earth. Some of them are nearly 10 times the size of our planet. They are held there in a perfectly balanced tug-of-war, pulled in one direction by the moon's gravity and in the other by the Earth's gravity. These places are called Lagrange points, where, in effect, there is no significant gravitational effect. If we could park the International Space Station there, we wouldn't have to make constant changes to its orbit, as we have to now, because it orbits close to the Earth and risks crashing down into it. Not only are there dust clouds, but also occasionally small asteroids, sort of mini-moons. If the moon disappeared, these dust clouds and mini-moons would either shoot out into space or, in the worst-case scenario, be attracted by the Earth's gravity and crash into us. Goodbye life. Number 6. Cosmic shield. Every day, over 30 tons of space debris, meteors, asteroids and dust are traveling at huge speeds towards the Earth. Luckily, most burn up in our atmosphere. But without the Moon, the numbers would be vastly more, and Earth would be dangerous and intolerable. The Moon is really quite large. It's nearly a quarter the size of the Earth, and exerts a significant gravitational effect and diverts most of the space debris away from us. It's fortunate that we have our own cosmic shield to protect us. Number 5. Goodbye mountains. We're familiar with the Moon's gravitational effect on our oceans and sea, but it also creates tides of the very ground upon which we stand. As the Moon rotates around us, it can raise the height of the Earth's crust by up to 12 inches each day. Many minor earthquakes are caused by this. More than that, they'd probably be no awe-inspiring mountains. The Moon was probably formed by the impact of a protoplanet, Theia, crashing into the Earth and smashing a huge amount of its crust into space. If that crust had remained on the Earth, it would have been far thicker and more stable. Sounds better, doesn't it? Well, no. Because of the relative thinness and unevenness of the crust, it moves around the planet in the form of huge plates, known as tectonic plates. Where these separate, trenches, such as the vast ones in the oceans, open up, and where they bash into each other, mountains are pushed up. Bash is probably not quite the word. They actually move quite slowly, thank goodness. For example, the North American plate moves at about an inch a year. Doesn't sound much, but as a result, there are about 150 quakes a week in California. Number 4. Problems with wind. How would you feel if you constantly face winds of over 100 miles per hour? Planets spin, and their atmospheres, if they have them, spin with them. And the faster the planets spin, the faster the atmosphere moves. For example, Jupiter rotates in about 10 hours. Its winds, in other words, disturbances in its atmosphere, travel at about 100 to 200 miles per hour. Saturn, on the other hand, spins slightly faster and has winds of over 1,000 miles per hour. Without the pull of the Moon, and it's the drag effect, the Earth would rotate faster, and we could expect the entire planet to suffer hurricanes, tornadoes and winds that would make life almost unbearable. Number 3. All that glitters. We wear it on our fingers. It's in our smartphones, our computers, GPS units, and virtually all electronic equipment. It's even in our mouths as gold crowns. So many uses. But its relative abundance is down to a collision eons ago between the Earth and the protoplanet Theia. It is thought that, about 4.5 billion years ago, a Mars-sized rock called Theia hit our planet. The surfaces of each planet were cast into space to form the Moon. However, Theia's core remained, rich in valuable, heavy elements like gold, and the core would have generally sunk to the Earth's core and fused with it. Over millennia, through volcanic and seismic activity, some of these elements were lifted to near the surface where they can be mined and thus enrich our cultures and our technologies. Number 2. Life as we know it. We humans might only exist because the Earth has a moon. Life, as we know, started in the oceans. These early bodies of water contained chemicals which over time reacted together to form nucleic acids, which are the building blocks of life. In part, the gravitational effect of the Moon increased the concentration of these chemicals, bringing them closer together. Without the Moon's effect, the concentrations would have been much lower, and thus reduced the chance of interaction between the chemicals. Also, the Moon is largely responsible for the tides. These tides and currents have the effect of mixing the chemicals in the water, critical for promoting the necessary reactions. And finally, even if simple life had developed, it's unlikely that complex forms would have evolved. Why? Because the Moon, through its gravitational effect, reduces the number of asteroids and meteors that crash and have crashed into the Earth. The constant bombardment would have made the environment too hostile for life to develop as we know it. By the way, that's why astronomers looking for potential life-bearing planets consider finding ones with substantial moons to be almost essential. Massages and magnets. The Earth is a giant magnet, and for our sakes, thank goodness it is. All the time, the Sun emits charged particles that blast into our atmosphere, and unless there was something to protect it, they would completely strip it away. This is what happened to Mars. The red planet was not dissimilar to Earth once, with oceans and quite possibly simple life. However, something strange happened to Mars about 4.2 billion years ago. It stopped being a magnet. Why is this important? It's magnetism that shields the planet from the worst of the Sun's solar wind. It literally repels it. In the center of the Earth, there's a molten core of iron. As it flows, it creates the magnetic effect with which we are familiar, through compasses and the like. Why does the core flow? It's largely thanks to the Moon. The Moon's gravity massages the Earth and keeps the planet's core molten. Without the Moon, the core would cease to flow and no longer create the magnetism. Lose the Moon, and we end up like Mars. Not a cheerful thought.